Hi everyone, we are continuing in Module 1. We're still on Topic 1, Lesson 2. We finished the Getting Started already, and now we're moving over to Activity 1, Prime Factors. It says you just determine factors by cutting out rectangles with a given area. You use common factors to create larger rectangles. Suppose you wanted to determine factors for a larger number, but you don't want to cut out rectangles. How would you know whether you have a complete list of factors? So in this activity, you'll write numbers as a product of their prime factors. So you know product is answer to a multiplication problem, and you already know what prime numbers are. So we'll be listing out prime numbers as factors. So this is also known as writing the prime factorization. Did you know that you can express any whole number as a product of primes, only primes and nothing else? So kind of another way to name a number. Gives us an example. Tells us a factor tree is a way to organize the prime factorization of a number. And you can choose any factor pair to get started. So it really doesn't matter what you choose to start as long as it's a correct factor pair. So they give us an example. So they're going to try to find the prime factorization for the number 30. So we're going to begin with the number 30. Pick any whole number factor pair of 30 other than 1 and 30, because that just gets you back to 30. So they picked 2 and 15. It says draw a branch from 30 to each factor, 2 and 15. Since both factors are not prime, you're not finished. So what I'm going to have you do is always circle the prime one. That tells us that you're finished with that part of the branch and it's prime. 15, since it's not prime, you can draw another set of branches. And what factors can you multiply together to get 15? It would be 3 and 5. Those are both prime, so you circle those. So then it says use the factor tree. Now everything is circled, so we're done. Use the factor tree to write the prime factorization of 30. We always write it from smallest number to biggest number. So 2 times 3 times 5. He says the factor tree in the worked example is not the only factor tree that you can create for 30. Create a different factor tree for 30. How many can you create? Well, maybe we could do 3 times 10. 3 is prime, I circle it. 10 is not prime, we need to continue. 10 you can arrive at by multiplying the factors 2 times 5. Those are both prime. Notice we still have a final prime factorization of 2 times 3 times 5, just as we said here. What other two numbers can you multiply together to get 30? Well, how about 5 times 6? 5 is prime, we'll circle it. 6 isn't, so we need to add some branches to it and continue our tree. What numbers can you multiply together to get 6? 2 times 3. Those are both prime. And that's all the different numbers that we can do. All the different factor pairs to get a factor tree of 30. I'm just double checking to make sure of that. So 2, 3, 4 doesn't work. 5 and 6. Yep. Okay. All right. Turning the page. Actually, we're going to go to page 15. Create a factor tree and write the prime factorization for each number. We're going to start with 24. I'm just going to start the tree right here. I need two numbers to get 24. Well, maybe 4 times 6. Neither one of these are prime, so I'm going to draw a factor tree branch underneath each of them. So 2 factors to get 4, 2 times 2. Those are both prime. You circle them. For 6, we have 2 times 3. Those are both prime. So our prime factorization for 24 is 2 times 2 times 2 times 3. And we can check it. We should check it all the time. 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. Okay, 81. We could have also, for 24, pause for a moment. Let me just go back. You don't have to write this one down, just watch. I could have done 3 times 8. Here I would do 4 times 2. And 4 would be 2 times 2. I would still have 2, 2, 2, and 3. And maybe you did, for 24, maybe you did 2 times 12. That's prime. 3 times 4, that's prime. 2 times 2, those are prime. We still have 2 times 2 times 2 times 3. So see how we did that 3 different ways. Okay, so 81, I'm going to rewrite it right here. 81, we have 9 times 9. 9 is not prime. You can arrive at 9 by multiplying 3 times 3. 3 is prime. And this 9 would be the same thing, 3 times 3. So the prime factorization for 81 is 3 times 3 times 3 times 3. Okay, how about 96? Maybe you don't know any factors of 96, but you know it's even. So maybe you just want to start with 2, which we know is prime. So 2 times what gives you 96? If you want to just do the traditional division, 96 divided by 2, you can get 4 groups of 2 out of 9. 4 times 2 is 8. Subtract 9 minus 8 is 1. Bring down the 6. How many groups of 2 out of 16? 8. And that gets you 0, so 2 times 48. 48's not prime, it's even. So maybe 24 times 2. And for 24, we could just keep going by 2's if you wanted. 2 times 12. 12 is 2 times 6. 6 would be 2 times 3. Now we have all primes. When we rewrite it, let's count how many 2's there are. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So for 96, I'm going to write it down here. 5 of them. 2, 3, 4, 5. And then there's 1, 3. We better check it. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. And 32 times 3 is, in fact, 96. You have noticed that each prime factorization had repeat factors. You can represent repeated multiplication as a power. A power has 2 elements, the base and the exponent. So this part's review. We've talked about this. So the base is the big number. So here by base, write big number. It's the one that's written larger. And the exponent is the one that is small and raised up. It's up in the air. The base of a power is the factor multiplied by itself repeatedly, and the exponent of the power is the number of times you use the base as a factor. So the job of the exponent, it tells the base how many times to multiply by itself. Oops. So, in other words, no, actually, this one doesn't even want us to write it out. It says identify the base and the exponent in each power, then write each power in words. So the base is 7, the exponent is 5, and in words, we would say 7 to the 5th power. Or we could say 7 to the power of 5. On this one, the base is the bigger number 4. The exponent is the 8. We could say 4 to the power of 8. Says you can read a power in different ways, 2 to the 4th power or 2 raised to the 4th power. Or like this, 4 to the power of 8. So write the prime factorization for each number in question 3 using powers. So we had 24 was right here. We had 2 times 2 times 2 times 3. So we had 2 is a number that was repeated. How many times do we multiply 2 by itself? 3. So it was 2 to the 3rd power times 3. What about 81? We had 3 times 3 times 3 times 3. So that was just 3 to the 1, 2, 3, 4th power. And 96, we had 1, 2, 3, 4, 5 2s. So 2 to the 5th power times 3. I think that is it for this lesson. It is indeed. That ends activity 1.